Hello everyone. Let's continue our class, a program of foundation engineering. We will try to finish chapter 5 today about settlement of shallow foundation. Okay, so these are two parts we will talk about today. But the first one is just one slide, so it's not that long. And the last one we will see uh, the way we can estimate different settlement of a building, okay? Because we have been talking about settlement. So far, it was like a total settlement. But when you have a building with different, for example, shallow foundation, different footing, uh, two adjacent footing can have different settlement, okay? So this is what we are going to talk about today. The first one, presumptive bearing capacity. This is just one slide, as I said. So if you look in many code, many standard in America and everywhere, a lot of standard are giving some allowable bearing capacity value, okay, based on the soil type. But these standard, they are giving uh, these value for visual soil classification. Mainly, it is based on that. Okay, the standard don't consider stress history, water table, and foundation depths. Okay, and they even don't consider tolerable settlement. That's why this standard for allowable bearing capacity should be used only for preliminary guides. Okay, so that's what we have to say about the first part. The second part is about a tolerable settlement of a building. Okay, so as I was saying in the introduction, we have different type of settlement of a building. Now we are not talking about settlement of a foundation, a single foundation anymore. We talk about settlement of the whole building. Okay, so you may have this kind of settlement, this kind of situation where the whole building is settling uniformly. Okay, all sides of the building, the four sides of building, all settling the same way, the same, let's say, same speed or same amount of settlement. Okay, if you have that kind of situation, the building will not present any visible crack, no damage on the building. Okay, but maybe you might have some damage in the utility. We'll talk about that later. So if you have this kind of situation, I mean, you may have also this kind of situation where the settlement, the building is settling, not uniformly, but it settled in a way so that the building is tilted, okay? So tipping settlement. It also mostly without any damage, any cracks, okay? But you have this last one, very specific case, where the settlement is really different from when you compare one footing or one side to another. The amount of settlement is different. For example, this side is not moving at all, it's not settling at all, while this one is experiencing excessive settlement. So in this case, you will have this kind of cracks. Okay, building will be damaged. And maybe you know about this one, very famous case, Pisa, the tower in Pisa in Italy. And you can see that this one is corresponding to the settlement where the building is tilting. The building is leaning, but when you check, there is no severe damage, no much crack on the building, okay, due to settlement. So, in research, people study this building, and of course, people check what happened in the underground, why this kind of inclination happened. Okay, this is just to show you example of settlement. So this kind of settlement happen because subsoil is not uh, uniform, non-homogeneous subsoil, and the load of foundation can vary, even though you are making estimation that the settlement and the load of each footing should be this. Sometimes it can change. It cannot be exactly same. Each footing cannot be supporting the exact same uh, amount of load, value of load, even though theoretically you say you calculate it is same, but when the building is being in use, the load can change, can vary from one footing to another. Okay, and all this lead to settlement, different differential settlement. Okay, the amount of settlement of each footing will not be same, no matter how many uh, estimation calculation you did before building. Yeah, soil can change, can vary even within 1 meter. That's why we have a lot of complications sometimes. But anyway, uh, when this happen, we we cannot prevent it from happening, but we can try to estimate the amount of differential settlement. It's complicated, difficult to predict. Okay, and when it happens, it creates some extra moment and bending stress in your building, in your structure, and you will receive getting this kind of cracks. Okay, for the early damage, you will see some plaster cracks. Okay, some misalignment affecting some serviceability and aesthetic. Okay, maybe the building is still safe, but maybe not anyone is uh, willing to go inside. Some people will be afraid to enter. Okay, and you will have later even more severe damage, including some structural cracks. Okay, like the beams start to crack. Okay, and some reinforcement, the steel inside, the steel reinforcement also start to be corroded, corrosion starting to attack the reinforcement. Okay, and that will definitely compromise the safety of the building and will not be safe to be inside anymore. Okay, so if you have excessive differential settlement, okay, and angular distortion, don't worry, we will define what is angular distortion soon. Okay, if you have this, it can cause distress on your structure, on your building. Okay, what is angular distortion? The angular distortion is the ratio of differential settlement between two adjacent foundations, okay, to their span length. Okay, it means if you do the ratio, the difference in settlement divided by the distance between the two columns, the two footing. Yeah, and this kind of differential settlement or distortion, angular distortion, is like somehow accept it until certain level. Yeah, there are like a limit. So the serviceability may be threatened at the value between 1 to 300 and 1 to 500. Okay, but if you have this interval 1 to 150, 1 over 250, you can put building, the building can be in danger, it is ultimate limit state. So serviceability limit state is this interval, and ultimate limit state is this interval. Once again, I will define this. If you see 1 here, 300 here, it means the difference between the settlement of the two footing is 1, but the distance between these two footing is like 300. About that, this is just a ratio. It doesn't mean it has to be exactly this, but supposing that the difference settlement between the two adjacent footing is 0.05. Okay, so you have to check if the distance of between the two footing can satisfy this. Okay, so that the meaning. The differential settlement, the difference between the settlement of the two adjacent footing divided by the distance between these two. Okay, so this ratio, this interval is accepted for serviceability limit state, and for ultimate limit state, this interval is accepted. Okay, so each critical limit depend actually on the type of material and the type of building, type of structure. Okay, so if you are dealing with, for example, hospital, maybe it need to be safe, so the limit, the expectation are very high. Okay, and depending on the type of material you are you using steel or concrete, reinforced concrete, or wood? Okay, depending on the material you are using. Okay, this was about angular distortion. What about tilt? I think we saw several examples of tilt, including the tower in Pisa Tower in Italy. Uh, Tilt is not like the angular distortion. Okay, it doesn't necessarily cause distress. It is like this one. Okay, because this is tilt. Yeah. So this leaning tower in Pisa, Italy, the tilt is about 1 to 10. 1 over 10. The ratio 1 over 10. So some structure also can experience large total settlement with little differential settlement. So that the first slide, maybe first photo we show here, where the building is going down together. The differential settlement is very small, but the total settlement, the whole building is going as a block down together. If you have this kind of situation, then the building itself will remain functional and you will not see big damage on the building. Okay, but this can still disrupt some utility, drainage, and some alignment. For example, if there are some pipe in the building, this can make this pipe to crack.